So here you can see that, okay, this is my classification algorithm. We were talking about this particular notebook, and let's go to the, you know, below part. Now, instead of this, what we can do is we can simply create the one notebook. So I can share that notebook with you after this session, right? That, I think that might works. Okay, let me create the new notebook, and we'll see the over here. We'll talk about decision tree visualization. Okay, let's rename it and let's get started. So as we know, guys, basically when we when we want to, you know, visualize the decision tree, so at that time we need the data. Okay, so for this particular case, we will be using the one data which is already inbuilt data of the one of the library of Python, which is nothing but the sklearn. Like lambda function, okay, if you wanted to, let's say if you wanted to apply some particular function, let's say if you you have the data of you know, few columns. In that data you will find that the few columns are numeric, few columns are categorical column. So at that time, if you wanted to apply, you wanted to find out the mean of all the numerical columns, so at that time you can use the lambda function. So with the help of lambda function, you will find that it will be able to find out the mean, okay, in just one line of code. So that is a use case of lambda function. So guys, let's go with our visualization. Okay, for that, let's import few library. As we know, this is okay. Here I'm gonna show you how you can visualize decision tree. So for that, we need a matplotlib library. So from matplotlib.pyplot, okay, uh, not just, we can simply go ahead like this, import matplotlib.pyplot as plt. Okay, then we'll go and we'll try to, you know, import the data set. So for that, we'll be using import from sklearn import data sets. So here you will find that the lot of data set which is already there in the sklearn library, right? And I'm gonna use the iris data set. Okay, we'll explore iris data set after importing that. So after this, as we know, after importing the data set, we want to classify that data. We want to build the classification model on the data. So that's why I'm gonna use again sklearn, right, to basically, you know, find out, to basically create our data science classifier model. So that's why I'm gonna use the one of the method which is nothing but the decision tree classifier, right? So this is my, you know, the simplest we can say that the decision tree classifier model we have, right? One more thing, okay, we need to, you know, export the basically, you know, the tree, export the, we can simply say that the text. Okay, so I'll show you what kind of text. So for that we need tree module. Okay, from sklearn import tree. So let's go and run this. Okay, these are the few library which we need. Now see, okay, it is taking some time to, you know, execute this particular cell. So at that time, what you can do is, if some, okay, sometimes if the okay, in the running, if cell is taking so much time, so at that time you can simply, you know, interrupt it by using this particular button. Okay, so now here you can see that my cell is executed, so no need to interrupt the cell. Okay, when it comes to the confusion matrix, okay, it's basically totally depends on the interviewer. Okay, so like sometimes interviewer might ask you about the, you know, confusion matrix, explain the confusion matrix. and what are the different, the terms are there in the configure matrix, right? Now after this, let's you know read the data, right? So as we know, here we are taking the data from the sklearn, which is already there. So that's why what I'm gonna do is I'm gonna use iris. This is my data name, okay? And from the data sets module, okay, I'm gonna load the data. And what, okay, which data we want? Iris data, okay? Just load it, and here you will find that, okay, when we are dealing with this kind of inbuilt data, so at that time you can simply, okay, data is already splitted. So that's why you can simply use iris dot data. This is my x data and this is my y data. Iris dot target, right? So this is my y data in simple words. So now we got the x and y data, right? Now the third thing is that, okay, let's build the decision tree classifier model. Okay, as I saw you that this particular all the things, okay, in this particular classification algorithm, here you will see, right? Here you will see that, okay, I already show you how you can go ahead and build the decision tree model as well as logistic regression model. So I guess again no need to explain this thing again in this particular session as well. Okay, so now let's go and build the classification model. And as we know, I'm gonna use this particular model. That's why I simply just copy this model from here, decision tree, and inside this just use a random state parameter. Why random state parameter? Because I already told you why we are gonna use a random state parameter. So you can add any random value over here, okay, to to get the same result each and every time, right? And after this, simply after building the model, here you can see that we just build the classifier. Now we wanna implement that classifier on my data. So for that, I'm gonna use a classifier dot fit on my data x and y. Okay, let's go and run this. And here you can see that we just created the decision tree classifier, right? Now let's go and basically let's import the text of the classifier, which means that import the different the our decision trees criteria, okay, that I show you yesterday. Okay, I'll show you again here also. Okay, so for that I'm gonna use text representation. Okay, text representation. I'm gonna use tree export text, right? And my classifier, I just wanted to explore export the text of my classifier, okay? And just to show you, I'm gonna print the text representation, right? So let's go and run these, and here you can see. Now I guess, okay, this is here you can see. Okay, now what is this, guys? What is this? Basically my tree starts from here, from feature 3, okay, and basically depends on the information gain. This is my one particular method. With the help of that, okay, we can find out this kind of statements, okay, because here you can see that if feature 3 is less than or equal to 0.8, so you can simply classify this as a class 0, because here you can see that in the target, okay, if I show you the target, so here you can see that the 0, 1 and 2 means total 3 classes are there. How many classes are there? Total 3 classes are there. So this is not the problem of binary class classification. This is the problem of tertiary class classification. There are 3 classes, right? So also you can say that it's a multi-class classification problem. More than two classes means multi-class classification problem, right? So here you can see that this is, I just, if this condition is true, simply I'm gonna classify my data, that particular row, as a class 0. Otherwise, if this condition is not satisfied, I'm gonna, further go and check this particular condition. Okay, if this condition true, I'll check this condition. If this condition true, I'll check this condition. Okay, likewise I'm gonna check the multiple conditions. Okay, and simply I'm gonna, you know predict this thing. So now here you can see that this is just the text. Okay, this is just the text. Let me convert this text into the visualization so you can understand, right? Now for that, okay, let me just go and, you know so here you can see that, okay, we are using, let's say, uh, one particular, the with statement. So you can simply, open the decision tree log file, which means, you know this particular, you can just write this all the things into the decision tree log, right? And then we can use that particular thing to, to get our plot, right? So let us go ahead, guys, with the our part. So now, guys, here you can see that what we are doing is we are trying to, import that all the data, this particular, all the text, okay, in the decision tree log file. So that's why I'm gonna use the decision tree dot log file. Okay, and here you can see that you will find that, okay, I'm gonna write this thing. Okay, I'm gonna use the W for write this thing, okay, as found. And here you can see that I'm gonna write which thing, this thing. Okay, write our text representation. Okay, okay, this is the thing. Let's go and run this. And after this, what we can do is we can simply plot the, our tree. So for that, okay, let's see. Basically, if you see that, okay, our present working directory. So how to check the present working directory? Here, if you wanted to see the present working directory, for that you will have to import the operating system library, OS. Okay, and by using OS you can simply use the get current working directory, get CWD and brackets. And here you can see that this is my current working directory, right? Now after this, okay, I'll use this thing. Okay, I'm gonna use the figure. Okay, because here you can see that we are trying to now plot the decision tree. So I'm gonna use plt dot figure. Okay, and in that, okay, I'm gonna mention the figure size. Okay, I'm gonna mention the figure size. Like, as we know, the tree is a bit big, so that's why I'm gonna use a, let's say, 25 by, 20. Okay, I think that might works. So after this, let us go, okay, and, you know use the tree dot plt. Okay, now tree dot, you will find that sorry, the plot tree, right? And here you will find that, okay, I'll have to add the particular classifier over here. Okay, I'll have to add the particular classifier over here. Okay, and if you go ahead with this, so here you can see that I'll have to, you know few feature names over here, few parameters I'll have to add over here. So first parameter is nothing but the feature names, right? So I'm gonna use the iris dot feature names. Okay, so here you will find that my data set, okay, already giving me the feature names as well. Okay, then I'm gonna use a class name. Okay, so here you will find that the class names iris again, okay, iris dot our target names, right? Then here you will find that just, okay, just fill all this information in my decision tree. So that's why I'm gonna use the field equal to true, right? So let's see. Okay, yeah, now here you can see that, because see I used a 20 by 25 by 20. Okay, so which means that to show you each and everything. So okay, now here you can see that in the first square, this is my root node. Okay, this is my root node, and here you can see that if this particular condition true, if this particular condition true, so here you can see that, okay, we got the class as the setosa. Okay, which means that here you can see that this particular class is nothing but the setosa class. Okay, this particular class is going to be the setosa class, means let's say the class 0, because total how many classes are there? Okay, total 3 classes are there in my data set: 0 class, 1 class, and 2 class, right? Total 3 classes. So this is my first class. Then I'll have to, otherwise I'll have to go and check the another condition, okay, with another column, you can see. Okay, now after this, okay, you can see that, okay, I just splitted my decision tree into 2 parts. Okay, so here you can see, okay, here again, if you go here, you can see that again I just splitted my decision tree into 2 parts, and here you can see in the last, okay, class is versicolor. Here you can see that the class is versinica. So these are my leaf class. So guys, okay, basically this is the, when, okay, see, this data is totally new to you, right? This data is totally new to you. That's why, okay, you are, there is some kind of lack of understanding is there for you. Okay, if you understood the data, if you understood the data, so at that time, okay, you don't have to face any problem to explain this particular decision tree in front of your stakeholders or your manager, right? Because as I told you the one decision tree in the yesterday session, okay, about the whether you can accept the the offer or reject that particular offer, then at that time you understood that particular scenario, because that particular scenario you can compare with yourself. Okay, but this data is totally new to you. That's why you are not at that time, it's it's bit difficult to understand this thing. But if you get your hand dirty with particular data, iris data, then you will definitely understand this particular decision tree, and you will definitely able to explain this particular tree in front of anyone. You will have to understand the decision tree, okay, theoretically how the decision tree is implemented on any data set. Okay, how decision tree is implemented on any data set. Okay, but I have that theoretical problem, and I can explain you that as well, but again we need to more than 30 minutes or 1 hour for that. Okay, and for this particular we have the as I am frequently saying to you that there is some kind of time limitation is there, right? So this is nothing but a data visualization of the this is how you can visualize the decision tree. Okay, try to go ahead with this particular data set. Okay, as I am sharing this particular code with you, and try to after the this particular session you can try to again 2-3 times, okay, try to run this code. Guinea index, again, as I told you, Guinea index, this is the one of the attribute selection measure. We have the total two attribute selection measure. Let me, open the whiteboard. So now here you can see, guys, okay, if we're talking about the attribute selection measure. So at that time, you can see over here is, okay, there are two attribute selection measure. First is nothing but the information gain, you can see, and second one is going to be the, gain index. So if we're talking about this information gain, so here you can see that you will have to go ahead with the, the attribute means the feature. Okay, feature selection. Let's say how many columns are there in your data. Let's say x1, x2, up to so on x10. Okay, so what will be the first variable? Okay, for your root node, let's say x7 is your root node, and then you just created the another, let's say x5 and x3. Okay, that is nothing but your attribute, right? So here you can see that, okay, this is your entropy. Okay, if you talk about the entropy, so you can write the entropy like this, h of x. Okay, so here we will be talking about the two classes of my y, 0 and 1. So that's why you will find that the entropy of particular, we are talking about the entropy of your overall data. Okay, let's say entropy of your overall data, you can say. Okay, entropy of your overall data minus the entropy of your overall data in that particular class. Okay, entropy of your overall data, okay, with your this particular, let's say that particular data, which means the column, any column, right? So here you can see that if we're talking about this, how to find the entropy, how to find the entropy. So for that, okay, let's say you will have to know the entropy formula. Okay, let's say how many x values are there. Let's say there are two x values are there. Okay, so for that you will have to use this thing. So here, now what is this? Now here you can see that, okay, probability of x. Okay, but here let's say take the x equal to 1. Okay, we are using this x equal to 1 into log with the base 2 probability of x equal to 1. Okay, then minus probability of x equal to 0 into log with the base 2 probability of x2 x0, right? So this is how you can find the entropy of overall data. Now you will have to, take the subset of your data according to your that particular column that you are finding out the, entropy for that. So you will have to take the sub part of your data depending upon that particular column, right? You will have to check that again, and you will have to go with this particular entropy formula, right? This is your whole data's entropy, this particular whole data's entropy, and this is your, that sub data's entropy which is related to that particular column. Okay, so again, okay, you will have to go with this. And if you wanted to go with the Gini index, so simple formula for Gini index is nothing but the PIXI. Okay, probability of each class, okay, into the probability of that particular each column, right? So in that way you can simply go ahead with, okay, and because this is again the theoretical concept, as I told you, the theoretical concept of logistic regression. So for that, okay, how much time we got, okay, like we spend for that particular logistic regression around more than 2 hour, I guess 2 and 2.5 hour, okay, to understand only that much. Okay, simple thing. So here decision tree is a, a bit critical. Okay, again, so that's why I didn't go there. right? There are, 5 columns. Okay, sepal length. If you see the data, okay, just go and explore that particular iris data. Which one? Iris data. Okay, you will find that the sepal length, sepal width, right? Then petal length, okay, petal length and petal width. And lastly, you will find that the target over here, the target column. In the target, you will find that the how many labels, setosa, versicolor. Okay, iris is nothing but the flower name, and there are 3 species of this. So setosa is the one species, versicolor is nothing but the another species. Okay, and virginica is there. This is another species. Okay, these are the basically 3 different species of this particular flower, iris flower, right? And you will find that this all this sepal length, sepal width, petal width are all the continuous variable. You will find all the continuous one. Okay,